Hi, today I'll be talking about this buck converter. This buck converter is LM2596. The problem with this buck converter is that whenever the output load is small, like a small DC motor like this one, it draws around 40 milliamps of current. So no problem whatsoever. There is no voltage drop at the output. But whenever the load is big like this one, this servo takes around 400 milliamps at max. I've tested is using this multimeter. It takes around 400 milliamps of current at max peak at stall, what do you say. Now the problem is whenever this is taking a huge amount of load, whenever this is taking a huge amount of load, the output voltage drops. This LED can be dimmed because of this. I can see that the LED is dimming constantly whenever this is going from 180 degree to 0 degree, 0 degree to 180 degree. This is the problem that I was thinking on solving. So what I did is I did some soldering. What I did is I added a 470 microfarad capacitor at the output and also a ceramic capacitor of 0.1 microfarad. What this will do is the 470 microfarad, the bigger one, will give the short burst of load. Means whenever there will be a huge current demand or a current surge like a servo or any LED which is switching on and off, any of that sort, the instant current rush will be given by this, the bigger capacitor, and the smaller capacitor is for switch filtering, high noise filtering. The IC on this, the heart of this chip, is this IC. The name of the IC, if I can correctly tell, I can't actually from this angle. So this is the switching IC. This is the main heart of this thing. What it does is it does the switching to get the output voltage at the desired by this potentiometer, and this is the inductor coil, and this is the output capacitor, this is the input capacitor. Now these are not enough for this. That is why I have added externally this, and the smaller capacitor, the smaller ceramic non-polarized capacitor, this is for high noise filtering, which the ESP32 is very sensitive to. That is why I have added this one. Now the solution that I've got, I'm quite happy with this, because I have probed when I'm using this servo. A small sketch is uploaded. So if I use this servo, like this is the positive pin of the servo, I'm connecting it. If I'm using this servo, you can see that the servo is moving, but the LED is not dimming. See, it's constantly glowing. It's not dimming whatsoever. So the circuit is working properly. The mod was worth it. So if you are also using a cheap DC to DC buck converter and you are not happy with its output, you can do some soldering and add a small capacitor at the end. It's 470 microfarad is not very small. It's a medium sized capacitor for this kind of things. And but the ceramic one is, these are very cheap actually. I have multiple of this lying around, that's why I'm using it here. And now I can use this buck converter anywhere. There will be not anywhere like for small loads, but it will be more efficient as the voltage will not drop, so sensitive components will not be damaged. I have probed it. Actually I have only 2 hands. God should have given me 4, but because of this limitation I can't show you the voltage. What I was doing before recording this video was I was probing these 2 ends with my multimeter, and it was constantly at 5.44 volts. But previously it was dropping from 5.4 before the mod to 4 volts to 4.8, and then at no load it's coming back. And now that issue is solved because these smaller capacitors are not enough. The company should take some more money and do this by themselves only, or you can do it by watching this video. This is a ceramic capacitor. The left one, camera please focus. This is not focusing. The left one is the output positive. This is a polarized capacitor. The ceramic one is non-polarized, but the electrolytic is. So you need to maintain the polarity or you will blow the capacitor in your face. Thank you.